Hello. I wanted to take some time to hopefully briefly go over some of the lateral loads and bracing fundamentals that are really important as a baseline to understand subsection 923.13. Subsection 923.13 is entitled Bracing to Resist Lateral Loads Due to Wind and Earthquake. So we're just going to break this down a little bit. So lateral loads, what are lateral loads? Let's consider this picture on the screen currently as a very simple plan view of a house or small Part 9 building. And as just a basis for us to try and understand lateral loads. So lateral loads are loads that are going to be approaching our building from any direction around the horizontal, so from the sides of the building. For the cases that we're considering in Part 9, we're considering lateral loads that are produced due to wind and earthquake forces. But lateral loads could be produced, for example, by like a vehicle hitting a building as well. But for the purposes of Part 9, we're considering lateral loads that are created due to wind and earthquake. Just important to recognize that lateral loads are loads that approach our building and act on our building from the horizontal, and that they could be coming, essentially from any direction or any bearing. Now, for the purposes of Part 9, when we're designing our buildings to resist lateral loads due to wind and earthquake, we simplify the fact that loads could be coming from any direction, and we design our buildings to understand lateral loads coming from only two orthogonal directions. So that's how I have it presented here on the screen currently. Now, this makes a lot of sense generally for small buildings because most of our buildings are, generally pretty simply constructed, usually just through a series of right angles or a series of boxes or rectangles that are joined together. So when we're trying to understand lateral loads that are acting on our building and design bracing to resist those lateral loads, we consider those lateral loads to be approaching our building and acting on our building in two orthogonal directions. Now, this concept plays out through various other provisions within this subsection, so it's just important to acknowledge here in the fundamentals. So let's consider a lateral load that is approaching the side of our building here. The purpose of Part 9 is to provide a prescriptive sort of how-to guide for designers and builders to design bracing to resist these lateral loads. And that bracing is established through the construction of the building and, through the prescriptive construction requirements produces a resistance to the lateral loads due to wind and earthquake. The idea here with this slide is just to understand that the resistance that we're providing in our building through our Part 9 construction requirements is going to be acting in an opposite, or directly opposite to the lateral loads that are approaching our building. This next slide here, very rudimentary in its appearance, but essentially this is to represent an elevation of a simple Part 9 building. Basically, the vertical lines there represent a stick frame building. Obviously, the triangle at the top is the roof, and the white rectangle at the bottom would be the slab on grade, or in other instances could be a wood frame subfloor. Now, again, lateral loads are loads that are going to be approaching our building from the side. And in this orientation, we can see that the intention with lateral loads is to sort of push at our building and deform our building. Now, if we do not produce enough resistance to those lateral loads through any sort of construction requirements, the effect is that lateral load is going to want to deform our building. So sometimes this may take the look of like racking. They might be cracking in drywall. In extreme circumstances, there may be sort of a collapse of a structure. Or various other sort of deformations that occur due to lateral loads that are sort of pushing or pulling at the sides of our buildings. So the intention, as I said before, with Part 9 prescriptive design, and in particular this subsection 923.13, is to provide enough resistance to lateral loads to overcome the lateral loads that are created due to wind and earthquake. So we given a guide in Part 9 on how to do this. And so first off, we provide vertical bracing to our light frame stick structure, light framed wood structure. And so this vertical bracing is generally provided by sheathing, and that could be a panelized sheathing like a plywood or an OSB. Could be a gypsum board sheathing as well. And in some circumstances, the code permits diagonal wallboard to provide this vertical bracing element. But typically, on modern homes, we're seeing plywood and OSB providing this vertical bracing. The idea here is that we panelize a section of light frame stick wood construction. And so by nailing or screwing that plywood or that drywall to the framing, we produce a resistance to lateral loads. And essentially, these are a vertical element in our bracing system. Now, between these vertical bracing elements, we also provide some horizontal resistance to lateral loads by connecting these bracing elements. So we do that through our roof sheathing and our ceiling sheathing, and we also provide a horizontal bracing element through our subfloors or our foundation. Now, it's important that we connect these systems together, and so the building code, Part 9, provides prescriptive requirements on how to make these connections between the vertical bracing elements and the horizontal bracing elements. If lateral loads are increased, so say for example we decide to build a building where there is a higher seismic risk or a higher wind hazard, the lateral loads that our building could be exposed to are going to be greater, evidenced by that larger arrow there. And so subsequently, we're going to have to design bracing into our building that is also increased. All right, so to do this, we make our vertical bracing elements larger. We make our connections between them on our horizontal bracing elements stronger, and then we increase the amount of connections between those two elements, between the vertical bracing elements and the horizontal bracing elements. And so with that, we're able to provide enough resistance to overcome larger lateral loads. Now, just going back to this very rudimentary picture here, this is basically demonstrating the three aspects of a bracing system that Part 9 is generally interested in. I've described them previously as sort of vertical bracing elements, horizontal bracing elements, and then the connections between them. But Part 9 of the BCBC has very specific terms that uses for each of these bracing elements. So first off, we're going to start with the vertical bracing elements, and we call these braced wall panels. Now, braced wall panels are a physical element that is constructed in our buildings, and braced wall panels have a very specific requirement, construction requirement that plays out in the design. Next, we have our horizontal bracing elements. So these are going to be our sheathed roofs, our sheathed ceilings, and floor framing. Now, of course, these could be sheathed with different kind of materials. Our roofs are usually sheathed with a plywood or an OSB. Our ceilings are typically sheathed with a drywall, and our subfloors are usually sheathed with a thicker subfloor sheathing. But again, these horizontal elements provide a horizontal bracing connection or a bridge between the vertical bracing elements, the brace wall panels. Finally, we have the connections between the horizontal and vertical bracing elements. And so in the top there, between the brace wall panel and the ceiling and roof framing, we typically have framing connections. So these are going to be created through nails in Part 9. And at the bottom of the brace wall panel, say for example, we're connecting that brace wall panel to a foundation, we're going to connect it with anchorage. So that's going to be our anchor bolts. If that brace wall panel happened to be sitting on top of a subfloor, a wood-framed subfloor, then again, we're going to make that connection between the vertical bracing element of the brace wall panel and the horizontal bracing element of a wood floor framing with framing connections, which are nails in Part 9. So all of these elements come together in very specific ways in Part 9 to provide resistance to lateral loads. But how do we know essentially how to design these systems? Well, Part 9 of the BCBC gives us another term, and we call that brace wall bands. Now, brace wall bands are a concept in lateral bracing design, Part 9 lateral bracing design. They are not a physical element that gets constructed in our buildings, but they're an imaginary concept that essentially provides a framework around our building to help us understand how to appropriately and accurately design a bracing system for a type of building. We're going to go over brace wall panels, brace wall bands, and connections in much greater detail. So at this point, it's just important to understand that brace wall bands are a concept, and they provide a framework into understanding how to design, place, and ultimately construct our brace wall, our lateral bracing systems within our Part 9 buildings.